Well, if you're talking about, let's say, the here and now, well, that these practices are very well established. Um, but when we're looking at 5 years down the line or 10 years down the line, uh, it really depends on how computing is changing. The reason for that is, processing power has hit, with CMOS, it has hit a limit. Actually, all I'm trying to say, we have to see how computing develops, because CMOS has hit its limit. And what has happened is, if we are able to increase the chips, the nodes on the processors, on the semiconductors, then we know that over a period of time, the Moore's law has been doubling for the last 40 years every 18 months, and the Huang's law is doubling the memory every year. So what happens is over a period of time, there is only so far the semiconductor can go. The question then becomes, what next? So there are things like quantum computing, which are already in place. Quantum computers have already been tried and tested in banking and a few other places. So the big question is, will they actually replace your regular sort of CMOS based servers? The answer is, we don't know yet, but it may happen the next 10 to 15 years. So there may be a generational shift. We don't know when. But what we know for sure is, increasingly, the monitoring is going to be very sensor driven. So there will be a huge number of sensors at every level, measuring every parameter. I mean, currently DCs tend to measure about 200 parameters. That will increase even more. We will see also automation and bots inside the data hall. So you will start seeing bots that are able to come and do some of the manual work, which is done by your, let's say, networking engineer or your infrastructure manager, effectively. So those changes are also coming, because the allied technology has developed for that. So one aspect is, of course, computing. Then there is the aspect of security. Then there is the aspect of managing things inside. There is by itself aspects related to UPSs, or aspects related to storage, which is lithium ion is right now one of the better options over your regular VRLA batteries. But there are at least a dozen alternatives in nickel metal hydride, or even there are new products being developed. Material sciences is going very far ahead. So depending on how each product changes, your monitoring will change, but it has to be integrated and will remain integrated at the software level. So remote monitoring, autonomous systems, which are very sensor driven, is what we are looking for as far as the future is concerned. There will be a disruption, and I'll tell you, there will be a disruption vis-a-vis quantum computing, quantum cryptography, both of those. We don't know yet when it will come. To be commercially off the shelf. So, that can happen 10 years or 10 to 20 years. So it's already out of the lab in application trials. So it's TRL level 4, TRL level 5, and then we will possibly see a change on that. So that will disrupt the way DCs function, and investments in the entire ecosystem. That all that will be challenged when that happens. So that's what I really wanted to say.